Hello students, and welcome to the last video of this lesson. I have a treat for you this time where we're going to cover two different problems, and you are going to need your calculator one last time. So let's get started. So in this first problem, we're going to be looking at a can of radius 10 millimeters that is going to be measuring rainfall in a certain town or city. All right, so we're given a lot of information in the prompt, and notice here that in the first 5 days, we're given an initial value of 3 millimeters. And then every day after that, we're given a function to determine the rate of the height of the can, the rain in the can rising. So first we want to find the value of the integral from 10 to 15 of s prime of t dt and explain what this means. So let's go ahead and get our calculators and figure out what that is. All right, and so I got 11.159. So I'm going to say here that the integral from 10 to 15 s prime of t dt is equal to 11.159. And then the units for this is going to be millimeters, so that's going to say millimeters. So 11.159 millimeters. So what does this mean in the context of our problem? Well, this is going to represent the amount of change of the water from 10 to 15 days. So if we knew like an initial value of 10, we knew that we're going to know that it is going to change by 11.159 millimeters in that can. And of course, you always want to point out that this is going to be measured in days, and we're going from 10 to 15 days. Now let's look at our second problem here, where at the end of the 60-day period, we want to know what is the volume of the water that's accumulated in the can. So I'm going to make a note here because we want to find volume. And how am I going to find volume of a can? Well, that's a circle times the height. So the volume is going to be equal to the pi r squared times the height. Well, we can use our function, the function given in our problem, to find the height in the can. That's what it gives. But the radius we are also given in the prompt. The radius is 10 millimeters. So we're given enough information here so that we could figure it out. But just note that when we find the integral at the end of the 60-day period, that we're going to be able to determine what this volume is. The other thing that I'm going to note here is that we're going to only find this derivative, or sorry, this integral only goes from 5 to 60. So from 0 to 5, we know that we have a starting point of 3 millimeters. So we're going to also take a note of that. So we're going to go here from 5 to 60, not 0 to 60, of s prime of t dt. And we're going to add in s of 5 into our final calculation. Okay, so we're going to add this in, and we're going to calculate this. We're going to go 5 to 60 here, and I get 163.56. Let's add in another decimal point, so 163.565. So that's going to be 163.565, and we're going to add in the initial amount of 3 millimeters. So our total amount for this comes out to be 166.565 millimeters. So now let's actually calculate our volume. So then when I actually calculate the volume here, this is going to be pi times 10 squared, which is 100, times 166.565. So let's put that into your calculators, and I get 52,327.9. Let's actually go more decimal places. And I got 52,327.938. And just keep in mind that this is going to be cubic millimeters because we just found volume. All right, so now we have a question about people entering and leaving concert. And this is another popular free response question on the AP Calculus exam. So you're going to want to make sure that you're able to understand, things going in and things going out and how that's going to affect a total amount. So we're given another initial starting point that we're going to want to figure out. What I'm gonna do it very similar to how I did it in the last problem. We're gonna calculate this from 0 to 2 hours. So I'm gonna write down R of T dt, and we're gonna add in the amount of VIP tickets sold. So we're gonna add in plus R of 0. So when I calculate this on the calculator, let's see what we get. All right, and when I calculate it, I get 980. So that's gonna be 980 concert goers for that integral, and we still need to add in the amount of VIP ticket holders that stayed around for the concert as well. So that's going to be another 100. So the amount of people that are actually in this concert is going to be 1,080 people. One thing to note is that if we were getting any decimals on a part of this problem, you're gonna wanna cut off those decimals because you can't have parts of a person. So also think about like what decimals might mean in terms of a context of a problem, which we're always doing here. But that's going to conclude this lesson. I hope you've been shown enough examples for you to actually tackle the homework assignment that's coming up. Of course, if you do need me to go over a problem or you do have a specific question over parts of a problem, please reach out to me. I'm Mr. Hernandez. This was Mr. Hernandez Teaches.